So last week, we talked about reflections and symmetry. This is going to wrap up section 2.7. Today, we're talking about, obviously, even, odd functions and translations. Here's just a reminder from the first part of 2.7. Don't write down, just think about it. You've already gotten stuff written down about this. This is about symmetry. It can get confusing with what we're talking about today. This is all about symmetry. So how do you check for symmetry about the y-axis? You replace all the x's with negative x. If the resulting equation looks the same as the original, you know it's symmetric about the y-axis. That's this one. Check for symmetry about the x-axis. You replace all the y's with negative y's. If the resulting equation looks the same as the original, symmetric. The origin, you replace all the x's with negative x, you replace all the y's with negative y's. If the resulting equation is just like you started with, then it's got symmetry about the origin. Now this came out of the book, but the origin one, I just need to make sure you realize if you had a pen right there at the origin and you spun this graph around 180 degrees, it would look identical to that. That's what origin symmetry means. Okay, that was from last week. Don't get confused. Don't confuse symmetry with what we're talking about today. First thing, even and odd functions. Don't write all this junk down. Just look at it. What are we really doing here? It says it's an even function if you replace the x's with negative x. And the resulting equation is the same. Now, wait a minute. That sounds familiar. If you replace the x's with negative x and the resulting equation is the same as the original, well, hold on. That's like symmetry about the y-axis, isn't it? That's exactly the same thing. So if they're talking about even functions, that's the same idea as symmetry about the y-axis. Okay. And then they're talking about odd functions. We're doing the same thing. We're replacing the x's with negative x. But now we're getting the opposite of our original. That means if I took our original function and stuck a negative sign in front of it, then I would have an odd function, and it would have origin symmetry. Now that one's a little weird compared to the way we checked for origin symmetry. So don't get confused. An even function, think parabola. Think it's got two arms. Those of you that suffered through pre-cal with me, we talked about this quite a bit, right? An even one. The arms are either going to be both up or both down. Think parabola. The arms are either going to be both up or both down. An odd function the left arm's going to be down, the right one up, or vice versa. One up, one down. And I don't think the textbook tells you that. I'm just letting you know. Okay, let's look at some of these. Unless somebody has a question about this. All right, we're going to look at several functions here. We're going to see, are these odd, are they even, or are they neither? So what do we do on all of these? We replace the x with negative x. So I'm looking at this, I'm saying y equals negative x to the fifth plus 2 times negative x cubed minus 3 times negative x. So every place there was an x, I'm going to replace that with negative x. And I've got, okay, negative x times negative x times negative x times negative x times negative x gives me negative x to the fifth. And then negative x times negative x times negative x for my cubed gives me negative x cubed. And then this would be plus 3x. Now I can change this right here to just minus 2x cubed, right? Scoot him over to there. Like that? Now, does that look the same as the original? No. It doesn't. So what do I know about the even part? It's not even. If that right there looked the same as my original equation, that would be an even function. It doesn't. Does it look like the opposite of the original? Did all the signs flip? Yeah. In other words, I could visualize that as minus and then these two are identical, right? The one in red is the opposite of my original. So that means this is an odd function. It's real mechanical. It's not something you're going to write in your diary. It's not going to be something you talk to people in the real world about. But that's an odd function. Here's what the graph of it looks like. Notice one arm's going up, one's going down. Does it have origin symmetry? Yeah. I could spin that around with the origin as the center, and it would look identical to that graph. Okay, so what do? We replaced all x's with negative x. We check to see, is my resulting equation, the last one there in blue, is it the same as the original? No, it wasn't. So I know that that's not an even function. I pull the negative sign out of all that stuff, and that is negative the original, so we know it's odd. Let's do another one. Okay, this function is x squared plus 6x plus 9. Now, y'all, that looks like the equation of a parabola to me. So can we just automatically say, yeah, that's got to be even if it's a parabola? Well, let's check and see. So I'm going to replace all the x's with negative x. It is waiting for you.
And we have orders.
All right. Negative x times negative x is x squared. This would be negative 6x plus 9. Does that look like the original? No. So we know it's not even. If I pull the negative sign out of all of that, Is the red one, is it the opposite of the original? No, it's not. That's not an even one, it's not an odd one. Here's the graph. Now, yeah, that is a parabola. And it's centered over that line right there. It's symmetric with respect to that x equals -3 line, but it's not symmetric about the y-axis, okay? So it could be a parabola, it's just scooted over to one side. So it's neither. So my function is 2x squared minus 3. So I'm going to replace my x's with negative x. So y equals 2 times negative x squared minus 3. Negative x times negative x is x squared. That's identical to the original, which tells me even. And here's the graph. Now this parabola is symmetric with respect to the y-axis. In fact, what we just did is the test for y-axis symmetry. Here's a question. What if I had a graph that looked like this? Give me a sec. That. What's the equation going to be? Maybe something like that. This would be a number here. And I ask you, is this an even or an odd function, or is it neither? Please realize that's not a function. So you wouldn't even answer the question. You go, well, hey, that's not even a function. How come? Well, it doesn't pass the vertical line test. So it's got to be a function for all of this stuff to be working. Remember, it's even or odd functions. Okay, let's go on. Please memorize this little form. Write yourself a note that if it's x plus some number, it's going to go to the left. If it's x minus some number, it's going to go to the right. All right, we're almost there. Look at D out there. Now, where the C number governs the left or right slide, the D number governs the up and down slide. So if D is bigger than 0, the graph slides up. If it's less than 0, the graph slides down. For instance, what if I had y equals x plus 1 squared minus 4. We're fixing to get into this, but whatever's going to happen there, what's that original, let me put it this way. The original graph would probably be a parent function. What's happening to that parent function here? It's moving 1 to the left, because there's a plus sign here. And it's moving 4 down because of that. So it moved 4 to the left. It moved 1 to the left. I'll get it. And 4 down. Okay. Let's look at one. So, how do you graph something like this? First thing you do is ask yourself, what's the parent function? Now remember, we have 6 of those parent functions we looked at that I asked you to memorize. We had what? The identity, the square, the cube, the square root, the cube root, and the absolute value. Make sure you've got those memorized. Which one am I looking at here for the parent function? The square. How do I know? Well, because of this right here. That 2. Something's being squared. Next thing I want to know is, what's A? For purposes of our class, is it positive 1 or negative 1? Positive. So that means what? It's not going to flip. Next thing I want to know is, what's C? C here is negative 3, right? Because if you look at my form that I asked you to memorize, this would be x minus a minus 3. That's why there's a plus in there. So this one tells me it does not flip. This one tells me it's going to go 3 to the left. Why? Well, because there's a positive right there. And the last thing I want to know is, what's D? Well, here it's negative 2, so it means 2 down. I need to know those things so that I can graph this function pretty easily. And think of it in terms of the parent function. Okay, let's really do that. So here's that same function. The homework questions are going to ask you to graph this. It's going to be a little weird the way the book has you do it online. But on the test, I'm going to give you some graph paper and just actually have you graph these. So here's my suggestion. First of all, what's the parent function? Well, we already decided it was square. So here's my parent function. Right there. Yes? Let's graph it. And I'm just going to use dots here. So when x is 0, y is 0, because 0 is squared. When x is 1, 1 squared is 1, so y is 1. When x is 2, y is 4. And so on. When x is negative 1, negative 1 squared is positive 1, so I'd have that. And then when x is 2, y is 2. So if I connected those dots with a nice curve, I'd have the graph of the parent function. So just put some dots there. I did them in black because I'm going to translate some stuff here. Now then, we know from the previous page that we're going what? 3 left and 2 down. That means for each point is going to go 3 left and 2 down. which would translate the whole graph if I could draw all the little points. Okay, so I'm just going to pick this leftmost point here. It's going to go 3 left and 2 down. So 1, 2, 3, 2 down would be here. So that means this little guy translated to there. Does that make sense? This -1, 1 point, it's going to go 3 to the left, 2 down. So this one translated to here. My 0, 0 point, 3 to the left, 2 down. So my dots in red are where the black dots translated to. My 1, 1 point, 3 to the left, 2 down. My 2, 4 point up here, 3 to the left, 2 down. And once you've got the dots, go back. Once you've got the dots, then you just connect them. And so the red is the graph of this thing right here. But notice, it's really a lot easier if you just get the parent function and just kind of sketch it in like I did, and then see where those main points translate. And then you can sketch that graph really fast. Well, that was fun. Let's do another one. What's the parent here? Absolute value. All right, so I know absolute value looks like this. When you see that parent function, you ought to think this shape right here. Now, since these are straight lines, I'm only going to need just a very few points to do the translation. Okay, so was the A here is -1. What does that tell me? So that means it's going to flip. C is -2 here, so it's going to go 2 to the left. So left 2. D is 1, so it's going to go up 1. So pick a point. I'm going to pick this one out here. I'm going to flip it first. So look what happens. It's going to flip across the x-axis, so that means it goes to here. All right, so the one I circled in blue translates, well, I should have written it in blue down here, shouldn't I? Because that's not the final spot for it. So it flips to here, and then it moves left 2, and then it moves up 1. So its final resting place is right there. So the first thing I did, I flipped it, I moved 2 to the left, and up 1. So I can erase these now. I'm going to pick the 0, 0 one, because these are straight lines. I don't have to worry about curves here. So 0, 0 doesn't flip because it's on the x-axis. Goes 2 to the left and 1 up. Yeah, so it's going to be right here. So the 0, 0 point moves 2 to the left, 1 up. Then let's get this guy out here. It's going to go 4 down below. to the left, 1 up from there. So once I've got those points, there's my graph. This can get real confusing if you don't have a method to do it. So that one, we just need 3 points to really translate it. So it flipped, it moved to the left, it moved up. It being the parent function. So far we've had a squaring function, we've had an absolute value function. Let's see what we've got next. All right, the parent here is a cubing function. So that thing. So looking at the parent, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. Let me... No, I'm not going to have room, am I? When x is negative 1, y is negative 1. When x is negative 2, y is negative 8. So that's down below here. I'm just going to kind of pencil it in right there. So you can see the shape of that. It's going to be a smooth curve coming through the origin, then turning down. So let's translate. What's A? Well, it's 1, so it's not going to flip. C equals 4 here. That's 4 right. D is 2, so that's 2 up. So each one of those points is going to go 2 up and 4 to the right. Okay, this leftmost point here should be at negative 2, negative 8. So what's that going to do? It's going to go 4 right and 2 up. So that should put it at, what, 2 and negative 6? Right there. The negative 1 point, 4 to the right, 2 up. The 0, 0 point, 4 to the right, 2 up. The 1, 1 point, 4 to the right, 2 up. And then this one up here is off the charts. So this thing is going to come up something like this. Okay, if we thought about it, what's the domain of this function right here? Just look at the graph. Is there anything x can't be? Anything y can't be? Nope. I just don't want you to forget about domain and range. If everybody's good, let's do another one. So there's 3 parent functions. We wouldn't have a complete set of notes without this one in there. Okay, parent function. Y equals square root of x. How do I know? Because there's a radical square root of something. So what do I know? A is -1. So it flips. Before I even get started, I need to know this. C is telling me what? It's going to go to the left or the right? Right? Correct. And D is -1, so it's going to go 1 down. So I'm going to graph the parent function now, just with dots. So when x is 0 for the parent, y is 0. So we got that right there. When x is 1, square root of 1 is 1. When x is 4, notice I'm picking values that I can take the square root of pretty easy. And when x is 9, 6, 7, 8, 9, square root is there. So I've got 4 reference dots there just on my parent function. So let's start translating. It's going to flip. Well, 0, 0 does not flip. It's on the x-axis. But it's going to go 2 to the right and 1 down. So 2 to the right, 1 down. So there, that dot right there is where the origin, the 0, 0 point, translates to. The 1, 1 is going to go 2 to the right, 1 down. Oh, no, 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 no. That one has to flip first. See, the 0, 0 didn't flip. This point right here is going to flip to here. And then it's going to go 2 right, 1 down. So 2 right, 1 down. And put that in red. Then this one is going to have to flip first, so it goes 2 below, and then 2 to the right, 1 down. Yeah. So the red ones are where we're in and up. And then the rightmost one on my parent function is going to flip first. So it's 3 above, so I'm going to go 3 below. And then from that point, 2 to the right, 1 down. So my red ones, in fact, let me just erase those blue ones. So the sketch of my graph would be this. What's the domain? What's the smallest x can be? 2. Okay, and it can reach 2. Thank you. What's the biggest it can be? Notice if x were below 2, let's say it was -1, under the radical I'd have -1. I'm sorry, if it was +1, I'd have 1 that, which is square root of -1. Don't want that. So 2 is the smallest x can be. The range, what's the smallest the y can be? Good. -infinity. What's the biggest it can be? -1. This point right here. All right. And each of those 4 examples we just looked at, we are taking the parent function. First of all, you have to realize what the parent function is. We're taking it and we're translating it based on what A, C, and D are. Here's another way the book's going to ask you to do these. We're going to assume they're going to give you a point. They're, like this one. Let's say 8 and 12 is on the graph of this function. They're not going to tell you what the function is because you don't need to know. These are super easy if you know that little form that I asked you to memorize. All right, so they're saying, we got some function. It might not even be one of those parent functions that we're talking about. It's a function. We're giving you a point on the graph of that function. You tell us where that point would translate to. So A here says, okay, let's change that function just a little bit. Same function plus 3. Now, what's that plus 3 telling us? It's not inside the parentheses, so it's telling us what? That's D. That says go up 3. Now, if I'm going up 3, am I messing with the x's or am I messing with the y's? Y's. So I leave the x's alone, so the point 8, I add 3 to the 12, and I get 15. That point would be on the new graph. That plus 3 out here tells you, oh, this whole thing's going to slide up from the original. So the only thing that's going to change is the y point. Just sliding straight up. Isn't this what we did for each point on those last 4 examples? Yeah. We took each one and just translated each little point. All right, let's look at another one. Okay, again, we don't have to know what that original function really is, but that 6 inside the parentheses is C. What's it telling us? Move 6 what direction? Left or right? Left. So now if I'm scooting to the left, I'm messing with the x's. So if I go 6 to the left of this 8, that's going to be a 2, isn't it? I'm not messing with the y's, so that stays 12. So that point would be the original point of the function, translate the 8, 12 point, translated 6 to the left. Now we're combining them. This negative 2 here says 2 to the right. This negative 4 says 4 down. Okay, 2 to the right is going to mess with the x's. It's going to change that 8 to a 10. 4 down is going to change the 12 to an 8. So I know that point would be on the new graph. Here's one, last one. Don't let it trick you. That negative sign out front tells me that it's going to flip. Now, if I'm flipping points, what am I changing, the x or the y? I've got a point above the x-axis. I'm changing y's. So this just says change the y. So what's the x is going to stay the same. What's the y going to become? Just that. Oh, I'm looking at this. Duh. Okay. There's a little slide on here that covers up. Yeah. All right. Now I got it. Thank y'all.